know about one-to-one functions? Or what do we know if a function is one-to-one? What else do we know? Well, let's start off with this. I'm sorry, maybe that's too much. What does it mean if a function is one-to-one? There you go. What else do we know about one-to-one functions? Or if a function is one-to-one, what do we know about it? What's the whole point of all of this business? Is it one-to-one, one-to-one, one-to-one?
The inverse of the function.
Careful, the inverse of a one-to-one function is going to be a function, yes. These things we do over and over and over again. Now, this was one of the last questions that you all had on your homework, so we're going to take a second. And again, make sure you've logged into your calculators because we're going to use the calculator. This was one of the, I think this was the last one, it was a calendar question. But the thing that's good about it is it gets us into using the calculator maybe in a little bit of a different way than you have before. So again, make sure please, if you haven't already, go through and sign into your calculators. What I need everybody to do is this. Go in and capture class. What we're going to do together collectively is start off, and we're going to graph that out. So the first thing that we're going to need to do is go to a new document, which would be a 1. And then we're going to go through and press, is it 1 for graph? Or no, graph I think it's 2.
Yeah.
So hit menu when it comes up. Oh, yeah, then add a graph. Now, go in please, and we're going to type in this quadratic expression, 2x squared plus 8x minus 7. And we're going to graph out that equation. Type the expression in and graph the equation. So when we do that, something fascinating comes up. Let's start off with this, because it says on the question, graph this and determine the domain on which the inverse is a function. What this is asking you is to figure out when is this going to be one-to-one? What do I have to do to my domain to make this be one-to-one? Is it one-to-one currently? You're looking at the picture of it right now. No. Now I'm going to say this, and this was kind of funny, because again, we get stuck with all of these zooms on it. We need to find where the vertex is. The vertex is someplace way down here. So what we're going to need to do is alter our window. Now before, in the last class, we did a zoom. The zoom ended up giving us a really distorted or awkward graph. This graph looks fine. I just needed to go lower. What part of this graph needs to change if I need to look a little bit lower? Do I need to change the y's or the x's? Hands up, please, if you can answer that.
The y.
The y's. Do they need to go higher or lower or both? Lower. So let's go into menu. Let's go into window, which is 4. And you can just press the digits. You don't need to always arrow up and down. Some people are constantly getting the wrong one. It's just a little bit quicker. Go to window settings for 1. Our x, max, and min are terrific. That's fine. Our y, min, and max we're going to want to change. So I'm going to make, and the max is even, the min needs to change. The max is terrific. How low do you think you want to go in order to see the turning point on the graph? You tell me. Is 1,000 a reasonable number? Let's try -20. If we need to modify from there, we can. So then go and you can just press OK. Now, am I able to see the vertex of that graph or where I need to restrict the domain to? Absolutely. The problem is estimating or using a table is a terrible thing in most cases when you can find out exactly where that minimum occurs. We need to find what the lowest point here on the graph is. I don't know how much experience you have with it, so we'll do it together. Go in, please, to menu. Now, we need to go through, if I'm trying to find the lowest point on the graph, which option do you think I would pick? Hands up, please, and give me an option you think you'd choose. Analyze the graph, so I press 6. Now, which of those am I going to be looking for? A 0, a min, a max, an intersection, a derivative, an integral, or a bounded area? Which one? We're going to try to find the minimum, so I'm going to press 2. Now, this is the good and the bad of this calculator. This little hand, finger thing, whatever it is. You activate it and you move it by going through and sliding around on this or using the arrows. But if you rub your finger on that little nub in the middle there, it's going to go through and activate it. You need to go somewhere to the left of your minimum and make sure you're safely to the left. This is a great spot right here. Then hit enter. And then you need to use your little slider over to make sure that you're definitely somewhere past it and hit enter again. And it will clearly indicate that you've hit a minimum. Now, another thing that you can do is this, and I struggle with this. See how he's got the little like claw right here, right? If you wanted to move this point, because we need to do it in the problem later, you, as long as it's the claw, I think if you hit enter on the claw, oh, not enter, sorry. Move over, move it to the claw, and I think if you push down on the center, then it'll grab it. Yeah, and then moving left and right will drag it around, okay? So, in any case, now you have the tools and you know enough to clearly state where you need to, well, we'll say this, over what interval do we have to restrict this domain down such that this graph is one-to-one. There are two acceptable answers. From where to where would we be looking if we wanted to break this down to be one-to-one? We got 1, 2 people that can tell me, 3, 4. Abby, what do you say? -2 to positive infinity is one of the two possible answers. That would be -2 to positive. By the way, this has an error in it right now. It includes the -2, so let's put a bracket there. And this is on a side note. Notice how that's like a firm bracket, okay? If we start seeing this to show how absurd some of your answers are, some of you start giving these. I don't know really what that is. It's as though the bracket and parentheses got together and did something inappropriate. Now there's some sort of offspring of the two of them that we have to go through and try to identify the parentage on. We don't do this. Maybe, and you know what I did? When we were doing this, I got so sick of this, where there's a group at U of R that they thought that they could get away with it, and then we started arguing over it. So I took my phone out, I took pictures of like 5 of them. And remember there was that poll that I sent out to you guys before about how much you wanted to use the computers or something like that? You can make it so it's a yes or a no or a true or false. So I said, is this a bracket or parentheses? And I displayed the results, sent it out as a picture. I displayed the results, and we discussed, and you could see it was like 60-40 every time. Maybe some, and there was one that it was 50-50 split. And that class had over 100 kids in it. So make sure that I know whether it's definitely a bracket or parentheses. Don't waffle on it. If I go from 2 to the right, or -2 to the right, that's going to be a one-to-one function. Or, what's the other viable option that I could restrict this down to be such that it would be a one-to-one function? We've got 3 of you, 4. That's what say? Perfect. Negative infinity to -2 works because that's from here over. That would also be a function. So either one of these works. Questions on that? All right. Let's bounce over now. Let's go and make sure you signed in. What page do we start today? 24. All right. Today's stuff hopefully is a little bit. I don't want to curse it by saying it's easy, but in reality, it's, at least in my opinion, quite easy. Piecewise functions are functions where you are defining the y value or output differently depending on what your x is. Sometimes you could have a piecewise where it's partially quadratic, partially linear. You could have one that is an absolute value in some regions and I don't know, there's an absolute value, maybe we can put it with a constant function. You could have 2 different parabolas. You could have it only exist in certain regions and not in others. They're really cool to go through and look at, and they model real-life functions in a lot of ways. Here's one that we look at. Now, take a look at this first example, and take a look. Here's our f of x piecewise function. Looking at that, it says, I'm going to graph that yellow expression, 2x plus 8, if the x is less than or equal to -2. I'm going to be graphing out the function x squared if it is greater than -2. There's a transition there. At what x value am I transitioning from the yellow graph to the green one. At what x value am I transitioning from the yellow graph to the green one? Noah, what do you say? At what x value am I transitioning from the yellow graph to the green one? At what x value does the switch occur?
-2.
At -2. So on your graph, I would go through and very, very lightly go through and sketch sort of an imaginary boundary line there. That helps you visually see I'm graphing one function to the left of it, one function to the right of it. Sometimes you'll need 3 of them, sometimes you'll only need 1. Looking at what's there, this yellow piece is a line with a slope of 2 and a y-intercept of 8. It does get a little frustrating sometimes that we need to show tables for everything, but you should. This green piece here is the parabola that's referenced in the other section. Notice, if I wanted to, I could continue this on forever to help build out what the graph in itself looks like, but only the piece in the interval I'm looking at is what I'm using. Now, what would our domain for this be? Taylor, what is the domain of this function? Take a look at the graph. What would your domain be in interval notation? For the graph as a whole, for the f of x. You can tell me what our domain for this graph would be. Got 1 person, 2.
-∞ to infinity.
Yeah, all of the x's are used. These two graphs, these pieces come together, that's what's defining the big graph overall. So my domain is -∞ to +∞. Now the range is the y values that we use. So Ben, what would our range be on this graph? It's unbounded below and unbounded above, -∞ to +∞. Falls forever and rises forever. Do not view it as 2 separate pieces. It's one graph defined by 2 pieces, but it's not 2 separate graphs. For the next one, we've got 2 pieces. First thing up is take a look at what's given. And hands up, please, when you can identify where the transition value is for question 1. What would our transitioning value be for question 1 as the f of x is defined here? We've got 1 person that can tell me, 2, 3, 4. Alexis, what do you say? Where am I switching from the yellow graph to the green one? At what x value? Yeah, at 1. So go into your graphs and let's put a very, very lightly done graph, lightly done line at 1. That's where we're transitioning. So what we're going to do in the beginning is I'm going to list out, I guess we'll do it as a table in the beginning, although once we get this done, hopefully you'll see you don't really need the table. Now, looking at what's there, it's the line y equals x plus 2. And I'm using, well, let's say this. Hands up, please, when you can give me an input that would require me to use the yellow graph. So this is my x, I'm using the yellow top graph. Look at the constraints on it. For what input? Give me a sample input that I would use if I'm graphing out that yellow piece. What do you want to say? 0. 0 would be the yellow graph. And give me another one. Who can give me another one? -5. Everything to the left of -1 I've used. So let's do this. Let's do -3, -2, -1, 0, and 1. Now when I plug a -3 into that yellow piece, Nathan, what would your output be? Abby, what do you get when you plug in a -2? No? Plug a -2 and you would use the yellow piece. What is that giving you as an output? And now, negative 2 plus 2. What's that going to give you? 0. Jessica, what do you get when you plug in a negative 1? John Paul, what do you get when you plug in a 0? And a 1 is going to give you a 3. Now, we are transitioning, so at our transition value, I always need to list that out twice because the transition value you need to account for in both the yellow and in the green. So when we do this out, I've got these points. So let's go through and plot them out. I've got negative 3, negative 1, so I go back 3, down 1, put a dot there. Negative 2, 0, here, here. Now, when I plot out 1, 3, is that going to be an open circle on the graph or a closed circle, and why? Come on. Why? Because it includes it. So I put a little dot after it. So I go here, and by the way, you know that this is a line with a slope of 1 and a y-intercept of 2. Do you really need the table? Some of us do, hopefully most of us don't. If you can fit the points, you show them, otherwise you don't get credit for giving a correct graph. And then this would extend down, so use something nice and flat and extend that graph out. Now, the other one is going to be this something very similar. The other graph starts at 1, even though some we're going to show why it does it. And then 2, 3, 4, 5, 6, and 7. So, when I plug a 1 in, I'm going to go back up. Now I've already plugged it into the yellow. I'm going to plug a 1 into the green. That's where the switch occurs. When I plug a 1 into the green graph, Erica T., what would you get as your output? Negative 1. What about when I plug a 2 in? Catherine? And negative 3, negative 4, negative 5, negative 6, negative 7. So I'm going to plot all those points. Is that right? Who says no? Thank you for being awake. Why? No? Look at the directions. In the green, you're only graphing it between 1 and 5. If it doesn't include the point, you're going to list the point out, but as an open circle. So I can get rid of the 6 and the 7. When I plot this out at 5, it's going to have an open circle. And when I start this off at 1, negative 1, it's going to have an open circle. So I'm going to plot this out. We've got 1, negative 1 with an open circle. And then these points going here, 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 and here. And then I end there. Is that right? The 5 is going to be an open circle too. Let's look at our graph now and answer some hopefully basic questions. Christina, what is our domain going to be on this? Find out a bracket at 5. Doesn't include it. How about our range? Gerald C., what would you give out as your range?
Negative 3 to positive 3 with a square bracket.
Questions on that? If you view it as pieces, it gets so much easier. And again, there's some people who will argue, I just type it in the calculator. Terrific, because you're going to get it wrong. And I'll show you why you're going to get it wrong with our next, I think the next example is the one after. This graph has 3 pieces, which means that there's going to be 2 transitioning values. You use the yellow at one point, the green at another, and the blue at another. Who can tell me one of my 2 transitioning values and graphing out number 2? 3, 4. What's one of them? Negative 5 is one.
3.
So I'm going to vary, and again, understand, these are not part of the graph. Negative 5 and it's 3. Now, I'm going to stay away from the table with graphing out at least the yellow piece. Who can tell me what the yellow piece is going to look like if I'm graphing out f of x, 4 x's that are less than negative 5? What would that look like if I graphed out the yellow piece on this graph? We got one person, 2, 3. Perfect. You're constantly graphing out a 4 here. So I literally do all of these points would get a dot here. The output's always going to be 4. Now, is that an open circle or a closed circle at that value, at the boundary value? Terrific. Now, the middle piece, yeah, I'm going to need to go through and use a table of values to get that one done. And I've got to do it from negative 5 up to 3. So I list down, say, all right, here's my table. I'm going to use this from negative 5 to 3. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. We'll show you a little gimmick to do the next one. When I'm graphing out that absolute value, plug the absolute value in. So it's telling you to take the absolute value of. Now, this is a word that most of you aren't used to hearing. It's called the absolute value of the argument. The argument is the input spot. So the absolute value of my argument, which is just what you're inserting in, then add 2. So, Eli, let's start with negative 5. When you plug in negative 5 in, what's the absolute value of negative 5? Nope. How far away is negative 5 from 0 on the number line? 5. And then what do you have to do to that number? Add 2. So what do you get as an output? 7. Now, let's do negative 4. And Cassie, what do you get when you plug in a negative 4? What do I get when I plug in a negative 3? Luke? What about when I plug in a negative 2? Nick?
2.
When I plug in negative 2 in again, what's the absolute value of negative 2?
Oh, 2 and 4.
Yeah, so this would be a 4 here. How about for negative 1? Alexa? How about a 0? Alex?
2.
Oh, this. How about a 1? Alex M? That's going to give you a 2 as well. Oh, sorry.
3.
Yeah. Then at 2, we would get out a 4, and over here, I would go through and get out a 5. Now, when I'm sketching this out, before I do it, though, I need to designate something about this value here and this one here. At negative 5, is this green graph getting an open circle or a closed circle? Jared, what do you say? Right here at negative 5 for the green graph? Closed circle, so I put a closed dot next to it. What about at the 3, Jared? Is that going to be an open circle or a closed circle? So now when I list my points out, I'm going to go to 3, 5, open circle there, closed circle at, was it negative 5, 7? So I put that there. Slope of 1 on an absolute value graph, it looks like a V. So you connect it using some straight edge to make it look terrific. Now, on the right-hand side, here's one that gets a little frustrating from my end. Allegedly, you guys went through Algebra 2 honors last year. And I say allegedly because we've had people, again, there was one, it's not just you, and maybe Calc the other day. The question was, what is 3 plus 4? Pick down somebody from the deck of misery, and I look at them and go, 7. These are the people that are going to be building the bridges that you drive over. That's what makes me nervous. Okay? Now, what shape is the blue? Let's start off basic. What shape is the blue graph? Hands up, please, if you can tell me that. What type of graph is it going to be? It's a linear graph. Y equals mx plus b form. So what's the slope on it? Hands up, please, if you can tell me that. 2, what's the y-intercept on it? Who can tell me that? All right. Now, that graph starts at 3. Instead of listing out a table, which you can do, and on a test or a quiz, I'd assume that you would do it. I'm going to start off and say, all right, well, that graph is going to start here. I know it's here, and then rise over right, so 2 over 1. So I'm going to keep doing that. Is this point actually used, though? No. Another one, not used. This one is used, and it would be an open circle here. Rise 2, right 1, rise 2, right 1. So it looks something like that. Did I need to list out a table of values? No. That's a line. You guys are in 10th grade honors math, and hopefully we can graph out a line. Now, the domain on this is going to be very, by the way, well, you'll see it when you do the domain. What is our domain? And we're going to have people get this one wrong. Talia, what is our domain on this going to be? I had people in the first class say the same thing, and maybe it's my explanation of it, because I said, what's it doing as we go to the left and to the right? You're not wrong, but you gave too much. Who can tell me what they think this would be? See how there's a hole in the graph there? Is 3 ever used in either of those graphs? Is 3 used in the making of either graph? No. So it's negative infinity up to 3. We're going to jump over the 3 and resume out at positive infinity. How about for the range? Robbie M., what do you say? 2? No? Well, that's, yeah, part of it. 2. No? Remember, it goes lower bound, comma, upper bound. How high does this graph go? To positive infinity. Are you using a bracket or a parentheses at the 2? Nice bracket. Questions on that? All right. Now, this is the part where, again, you all will be teaching me. And the only thing that I know from this, because I was at we were at a Master Teacher College thing this weekend. So, now, here's one. Before we go on, I'll show it to you in the beginning. This was one problem that we did earlier. Instead of going back to the home menu, deleting everything, starting off with a new document, blah, 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 we're going on to a new problem. Now, I don't know if there's other shortcuts. Here's the shortcut I know, is to do this. Let's ask this question. Are we doing a new problem? Yes. So go in and press dot, insert for a new problem. So that would be, notice how this is problem 1, this is problem 2. That's its sort of filing system. That's the operating system on the calculator. So we need to add a graph, so now I bounce down to 2. Now, this is how you would enter a piecewise function. There's 2 buttons that you may not have used before this year that you're going to become very familiar with. Here's your templates button here, which is a bunch of sort of forms that you fill the numbers in. So go in and select that, select the template. Now, this one right here is the one that you're going to be using for a piecewise function. I can't tell you how to find it on a test or a quiz. So that's the templates button. Now, how many pieces does this example have that we're going to be graphing out, kids? 4, all right. So type in 4 and hit OK. Now, the first thing you're going to do is enter what you're graphing, which is what 4 minus x is the first piece, and then it tells you where to graph it. So go over here, you're going to do an x. Now, to get your symbols, an equal sign, you just hit the equal sign button. If you need other symbols, you hit Control equal sign, and then a whole mess of other symbols come up. So you pick the ones that work for you. So x is less than -2. Go through and finish out typing this in. Now, once you're done, you'll hit enter and it'll give you a graph, right? Now, what I want you to do is this, if possible, grab this equation and drag it down over to quadrant 3 so it's not like right in the way of what we're looking at, because I need you to see something that's wrong about that graph. And the calculator won't tell you. There's programs actually, I can share some links if you're actually looking to graph them out on the computer to make it very easy. Who sees? So here's what the calculator is telling us. And here's our notes. So, who sees what's wrong? Or what the calculator got wrong on this? There's actually 2 things that I go through and say, yeah, the calculator has this wrong. Look at the function, because the calculator is telling you something wrong. It's not doing it because it's trying to be a jerk. It's doing it because there's a problem sort of with the equation itself. We got 1, 2 of you. Look at what's there. Analyze the situation and say, where's my discrepancy? Did you see a problem? Okay. It doesn't say whether there's open or closed circles. Can anybody tell me where there's an open circle that you're not seeing? The equation, where's there an open circle that you can't clearly tell from looking at it? Careful. Not at -2, because the -2 is used in making this graph here. And a +2. So this is one open circle that they've missed. That should be on your paper. It should look that dramatic, a nice, terrific open circle. What else is missed on this graph, though? This is the part I find fascinating, guys. I would jump all over this. Number? Yeah, the function value is -3 when x is equal to 2. Does the graph show this point? No. So there's flaws to it. And we say this, and this was my favorite thing. Apparently I said it so frequently. Someone decided when they got their brick to put it up there. You need to be smarter than a piece of plastic, because the calculator does a terrific job, but you have to be smarter than a piece of plastic. And somebody on their brick wrote up there that they in fact are smarter than a piece of plastic because they got a 100 on their exam. And that's when you, by the way, there's another one on here. For a long time I would say that it, like, mistakes were mind-numbing. And we do our thing at the end of the year, I can't remember which year it was, but they like wrote this whole like mind-numbing or something like that on there, and then I stopped saying it forever. So you have to be smarter though than the plastic that you're using. That's the hope. The hope. The calculator can do terrific things, but it can't think. And you can't. So let's bounce over, please. We're actually going to do 2. We're going to build a piecewise function first. And we may have to go through these a little bit quicker. How many, look over to 6A. Go over to question 6A. Hands up, please, if you can tell me how many pieces this graph is going to have if I told you to give it out as a piecewise function. 2. There's this piece right here, and then there's this piece over here. Okay? So when we're doing this, there's 2 pieces. Actually, I'll make this even bigger and more than this. This piece here, and okay. Now, if I'm trying to build out the equation, I would say, all right, the function is going to be f of x. There's 2 pieces. I'm going to ask this. When would I use the yellow piece? Hands up, please, if you can tell me that. When am I using the yellow piece? So in using the yellow piece when x is going to be less than or equal to -1. When am I using the green piece? Hands up, please, if you can answer that. One person. Terrible. Well, terrific. So, oh, greater than what?
Negative.
Negative. There we go. Now, when we do this out, we get to here. Now, I need you to tell me what the equation of these 2 lines are. Which equation do you think is going to be really easy to give? Which piece, which color is it going to be really easy to give the equation of the yellow or the green? Who can tell me? We got one person? Look at those graphs. You should be able to do this back in geo. Allegedly, they passed you in geometry. Allegedly. You've got to be able to give out the equation of the line. We've got 3 people, 4. My heart's breaking. Okay, you want to give the yellow? What's the slope of this line going to be? Oh, too much for that. Too much. Well, we can do the green one. Let's go. Well, then what's the equation of the green one?
Y equals
Let's start off. Lines, as you know them before this year, were in the form y equals mx plus b. The m stands for the, and the b is the. So I look at the green. Hands up, please, if you can tell me what the slope of the green line is. 1, rise over right, so this would be 1x or x. Now, what's your y-intercept? Hands up, please, if we can say what that is. Go ahead. So the green line is y equals x plus 2. If I extend out the yellow line, I can sort of figure out what its y-intercept would be. Who can tell me what the equation of the yellow is going to be? Seriously, 1 or 2 people? What do you say? Terrific. Terrific. Negative x plus 3. All you do is give out, you love y equals mx plus 3. You mastered it. So use it. Questions on that? Because there's one just, well, not just like this, but like this on the exam. Let's bounce over then and take a look at the next one. How many pieces are there in 6B? Hands up, please, if you can tell me that. Where are your transition values? Values. There's more than one. Okay. So I've got 3 pieces now I'm going to be graphing. I'm going to say f of x is equal to, and I need to leave space. When am I graphing out the yellow piece? Hands up, please, if you can give that out. When am I graphing out the yellow piece? X is less than or equal to -2. How about when am I graphing out the green piece? Hands up, please, if you can tell me that. Oh, come on. When am I graphing out the green piece? 3 people. Leah M., what do you say? Which would be less than? How about the third piece? Amanda? equal to what?
Correct.
This should be easy. What's the equation of the yellow line going to be? Constant function. What's the equation of the yellow going to be? 3 of you, 4, 5, 6. How about the equation of the blue? Hands up, please, if you can tell me what that one's going to be. 4. Now, the middle one, hopefully it looks shockingly familiar to you. Maybe something that would be really significant, that's feeling kind of confident about itself this week. There you go. There you go. Can you build those? Sure. Absolutely. Let's go back now and look at a different one. Here is the graph of the absolute value function y equals, or f of x equals, we have the quantity x minus 4. This is what it's going through and doing. I need to break this up into a piecewise function. Hands up, please, if you can. This graph isn't included, so you may want to include a sketch of it. I think it's 5. It's before the 2 that we did. Bottom of page 27. Now, looking at what's there, how many pieces does this graph have if I were to rewrite out this absolute value graph as a piecewise function? How many pieces would this graph have? We have 1, 2 people, 3, 4, 5, 6, 7, 8. Hannah D, what do you say? How many pieces? 2. There's this yellow section here, and this green one here. So I go through to build it up. F of x is going to be equal to, I list out space for 2 pieces. Now, Noah, where does the transition occur? 4. So this yellow graph I use when x is less than 4. This one I use when x is greater than 4. It doesn't matter which one you peg as it being equals. So Noah, which one do you want to get the equals? The first one or the second one? Doesn't make a difference. Second one? All right, we'll make it be the second one. Who can tell me what the equation of the yellow graph is going to be? 2, 3, 4. Nick, what do you say?
Negative x plus 4.
How about the equation of the green? Now, if you need to extend this out in your head, be like, gosh, if I continue this out, what would that look like? Who can tell me what that graph would be if I extended it out? It's a line, so you can do y equals mx plus b on it. 1 person. 2. Ben, what do you say? Let's start off with the slope. What's the slope of the green? 1. So what's the first half of the line going to look like? Now, if you were to drag this out and keep it going down, where do you think it's going to cross? If you were to take an educated guess. That easy. By the way, in an absolute value graph, what do you notice about these 2 pieces? Hands up, please, if you can tell me. What's the relationship between the 2 of them? They're opposites. One's the positive and one's the negative. Isn't that what absolute value involves? You take the positive and the negative of the argument. Now, your homework is to go through. If I were you, I'd finish up. Maybe I'd really take a good look at question number 4. I love question number 4, but unfortunately, we don't have enough time to get through it. Should be kind of easy. Piecewise functions, walk in the park. Don't enable yourself by getting married to these calculators in order to get them out. What I will say is your homework is on the calendar, so I would make sure that I went through and got that done. Next class, we're going to have a little bit of review and some calculator activities. And then, after that, your first of 9 Super Bowls of math, which is exam 1. Just wait. Maybe we'll even do this. We did it last year. Maybe we'll have you all, maybe we'll offer you guys if you want to get a math uniform for the Regents exam. So you walk in and look like an invading army. I'm so intimidating. Go through and kill it on the exam. Slaughter. I can't wait. I think I was telling you, I was bragging even yesterday how well you're going to do on this exam. So, the Thomas teachers, get your resumes ready. They're going to fire you all. I've got probably at least 10 to 1,500 easily. Easily. You don't even understand. They're going, what? You're going to do so terrific. Oh, one other thing, and this I acknowledge I'm terrible at. If you ever want, well, you want them back. I have a ton of your assessments over here. They're actually graded and everything. Remind me at the end of next class, I'll give them back to you. I keep forgetting to hand them back. There's a whole mess of them. If you ever want them, though, and you can't wait for me to time above to get them back to you, you can just walk over to the bin and grab them. Have a good day, kids. Yeah, whatever it said on here for day. Oh, sorry. Okay, 5. And yeah, and check out, remember the answers to that are posted? No, that's for your practice. Okay? Do this, take the F of 3 and the G of 3 and add it together. Don't overthink it. Okay? It's shorthand because if you write it that way, you don't have to write the 3 twice. That's the notation given. All right? Was there another one? This one here? No. That's one, see how it's nested inside? So I take 1/3, plug it into F, and get a number plug that into. Okay? That's an outside-inside one. Make sure the calculators get pushed down.